Hello guys, welcome back. In the last video, I abstracted LLM provider. Today, we are applying similar patterns to external service communication and external service connection and tools. Uh, Agents become really powerful when they can interact with external system, read from database, create GitHub or Jira issue, connect to Datadog, try to get some performance about the application deploying different environment, send notification. So the connection and tools framework make this possible while maintaining security control. So what I'm going to cover in this video series is the connection management abstraction, Jira connection implementation, just sample, but we have so many other connection there like MongoDB, Postgre, Confluence, but I just want to cover just Jira. And then I'm going to show you the connection factor and the caching, tool framework design, tool approval design, and how LLM use the tools. So this is what we're going to cover here. So the connection system provide like a uniform interface. Let me switch to the code so that we'll be able to see it. Um, Looking at the connection system, this provide like a unified interface for external services. So if I try to like sorry, I'm gonna close so that let me try to open this file again. I'm gonna scroll down to the connection section so that we continue. So now look at the connection interface. This provide like a unified interface for integrating with external services, like a database, GitHub, Jira. So if I want to manage the connection, for example, to my Datadog, to S3 bucket, to different other external services. So just like a LLM provider, I define an abstract base class, and every connection manager must say implement get connection name, validate config, connect, disconnect, and its heading method. And if you look at it here, uh, if you look at it here, this is the base connection manager, and every uh, concrete implementation, we should have a concrete implementation for this. Validate the config applicable to a particular uh, connection, and the connect disconnect is ready, is connected, is ready. These are the mandatory abstract method that respective connection domain need to like implement. So what is special here is the template maiden pattern. If you look at here, because I'm using like a templating maiden pattern here. So the base class handles configuration load automatically. So the child class is just say what my connection. So and the framework load their connection config from the application external file. So let me show like my Jira connection here. If you notice here, just a similar pattern like a LLM provider. So like a Jira connection supply its name. Oh, this is Jira. Automatically, this will try to get the name of the config. So get the name of the config and this make this config available so that the Jira could actually Jira connection manager could actually go ahead check for specific configuration details that's supposed to be in the Jira. Try to do all sorts of validation and ensure that this is work. So if you notice that there is the decorator at the top of the Jira at connection registry.register, this looking at it here, this automatically register the connection with the factory. So no manual registration needed. In connect here, uh, I initialize the Jira client and verify it works with a server info call. And I also try to check the F status if I can still communicate with the Jira. And the connection has a specific method called get issue, create issue. And also notice the decorator, for example, look at it, search issue, right? Also notice the decorator I'm using to do the retry for circuit breaker. Look at it here, get issue. So if you look at, I'm managing everything that has to do with the external communication here, right? Because I'm connecting to the external service, external API. So I'm trying to create like a communication to them. So the connection has all these specific, and you could notice the at retry and the cycle breaker. Those are the built-in resilience pattern. So if you request for it, it will try. If Jira is there, the circuit breaker prevent cascading failure, right? It prevent cascading failure. It will try based on this retry config that we have here, right? Based on this, if you check the settings app, you see the residence configuration that I did there. And the app here, in the app here, if you go down here, be able to see the residence. So this is where I configure the maximum retry, delay strategy, so stuff like that. And now, when we look at another section of the code, which is the connection factory, and the connection factory manage a connection instance using registry pattern. If you look at it here, here is it. And in my presentation file here, which I'm going to share, I put it here. This validate the type. It has a similar pattern like that of a LLM provider, where it will try to check if the connection is registered. The factory is simple. Get connection manager, takes a connection type inox, look it up in the registry. The registry know all the connections manager because they register themselves with the decorator, which I've just explained. So notice there is no catching here. Why? Because each connection manager handles its own life cycle. So when you call connect, it creates and store the connection. So when you call ensure connected, it check if the connection is ready and reconnect if needed. So you could check the code here. You could check the code here. The key features here: registry pattern, auto configuration, validation, and availability checking, right? So here, this is it. This is what I'm talking about. This is the usage example. Jira manager connection factory does get I pass Jira, right? I say this is how to use it. You can just say Jira client is your Jira connect, right? So imagine if I need access to GitHub, all I need to say GitHub. The only difference in here is the name. So which will make it to retrieve the right instance automatically, then I could proceed to use it. Look at the sample usage here. Connection with automatic reconnection. So if you say Jira manager.get connection, this this will check if not connected or reconnect if unhealthy. This is the reason here, right? So I just try to show different sample usage here, and connection health check here is being done here in this section of the code. You can see it here. Check all connection. So if you check, you notice that this the configuration where I manage the connection, for example, S3 bucket, this and that. So available type of connection, Jira, Confluence, database, vector. I have a Datadog, a lot of it, and you can check the code. And I still hope to keep adding new adding new connection, which are different tools. So in case you want to add new connection, all you need to do is check this enum type. For example, this is new. I define the Datadog, right? And all I need to do is register it and try to do all the implementation as well. You see, the way I'm connecting to Datadog is different here because I'm using the Datadog API client. So all you need to do is add a external configuration in the YAML file, locate this YAML file, add the configuration for Datadog so that it will be available. As you can see, I'm getting all these things from the settings, right? So which is flexible. And if you want to use it, Datadog, get Datadog, connect, then I will just proceed to do all kind of implementation. So I just want to add that all those external service integration like Jira, like Datadog, like Confluence, like GitHub, they are different tools that the LLM needs to perform its function. Understand that LLM has been pre-trained with a huge amount of parameter, huge amount of data that make it functioning efficiently. But if you want your business specific use case, this is why you need to integrate different kind of tools. For example, if I'm integrating GitHub, I'm adding GitHub so that my LLM will be able to know my GitHub repository and to use it to provide support. For example, it could read the Datadog and give me the error report. Support team could use it, and the LLM will be able to use the access it has to GitHub, to Confluence, to any external document to be able to provide solution to any kind of a support problem. So this is why I need to talk more about tools. And if you look at the implementation that I just did, where we have different connection that provide different access to different tools. So the the tools extend the agent capability beyond text generation. So if you look at the implementation here, you will notice that as part of that, I also have these tools, for example, GitHub, because if I have these tools, this is where I manage all the tools in the system. Jira, and you could disable, you could enable any tool. So when you disable these tools, it will not be available. It will not be. It means that LLM will not have such capability. For example, to use a Jira, if I disable Jira, or if I disable search Jira issue, it means this functionality will not be available. If I disable this, it means LLM will not be able to create Jira. You see how we create Jira, you see how we do everything uh, as we proceed. So the tools are configured in application YAML as I've just shown, and require approval flag is critical. So if you come here, you see that some tools require approval. For example, require approval, it means that this is critical operation, which must require confirmation from user before the agent will be able to create such tools. And we're going to see this in effect as we proceed. If you look at tools here, I have a base interface for tools. You come to the agent and tools here. I have the base interface for the tools, just like any other one. I have the Confluence tools. If you look at it here, no, this is what I design. I use a different design pattern for this. I have the Confluence tools. I have look at the pattern that I use here to design all the tools. Jira tools, right? And in the base here, I just have a registry here. So if you look at here, this is the YAML file configuration, right? And if you look at it, I'm still using a provider pattern, right? So that if you look at each of the tools, for example, the GitHub, right? Tool factory, right? GitHub tools, right? And in the GitHub tools, if you open it, I try to register GitHub, try to register different kind of tools here. And when you come down here, you see how I'm getting different kind of tools. I get connected to GitHub. Take note that this tool registry, the creator automatically register the provider with the framework. So if you look at the tool registry here, in the base here, it has a similar pattern, just like any other one. It has a register, and here, so if you look at the available tools here, these are the available tools, and I hope to extend these tools. I have the web, GitHub, Jira, Confluence, Datadog, VectorDB. Look, these are the different kind of embedding stuff that I've embedded. And if you come down here, where we have the web, I try to provide some examples, some instructions, provide some configuration, try to say documentation. We read. So these are just examples. So this could be organization documentation, right? Instead of this could be organization documentation. This could be different if you have different kind of a documentation you want the LLM to have access to internally within your organization, then you could achieve it this way. So how tools are used by the agent when creating an agent, tools are automatically discovered and loaded. So for example, if you look at a tools registry, say get all tools, enable only is equal to true. So this is going to return only the enable tools. So the agent framework load tools and provide them to LLM, which I'm going to show you. Basically, this is how I'm going to show you how the agent load is. This is how you are going to like add a new tools. If you want to add a new tools, for example, you say Slack provider, you want to have access to Slack through your LLM. You want your LLM to be able to do a lot of things. You need to like maybe send a message to Slack, this Slack channel. So you define this, and you need to add a Slack to the tools in the YAML file, and that is basically about it. All you need to do is you could control the usage. For example, tools, calculator, you can set, okay, enable tool, require approval, send email. So this is how you manage the tools, and you could see the sample usage here as well. When I'm trying to get a particular tools, for example, to register.get tools, web search. So if you want to test this programmatically, you could test this. Agent use these tools automatically as long as the tools are available. And this is just a process to add the new tools, to register the new tools. And this is how this works. So in the next video, we're going to talk about agent architecture. So you see how everything works together. Thank you.